Okay, so we have different types of functions. So the 4 different names that we give to types of relationships are one-to-one, many-to-one, one-to-many, and many-to-many. So if we look at those, we're going to have a look at what that actually means. So for a one-to-one function, that means for my values of x and y, if, for example, I had a straight line equation, so a linear function, this could be any linear. We know that it extends forever in both directions. So this is my axis with my x and my y. And each one x value, so for example this one here, it maps onto exactly one y value. If I pick a different one, this x value maps exactly onto one y value. You're only ever going to get one y value for each x value. So it's one x value for one y value. And that happens every time. So we also have many-to-one functions. So if we have a look at what that might look like. So I've got my set of axes, and I've got my x-axis and my y-axis. So an example of this might be a quadratic curve. So a quadratic curve looks like this, and it extends forever in each direction. Now this time, for every x value that I pick, I find a y value. But there's also another x value that I could pick with that same value of y. So this time there are many different x values for that one value of y. So I've got many x to one y, and I could pick a different one. So here I have many different x's, both of these, that go to the same value of y. Another example of that might be to do a cubic function. So a cubic function, again there's my axis, so I've got my x-axis and my y-axis, and a cubic function might look something like that. And on here I have one value of x going to one value of y. And I have one value of x going to one value of y. But I also have 2 different values of x that go to the same value of y. In fact, I've even got 3 values of x going to that same value of y. So in this instance, the function is a many-to-one because there's lots of different x values going to that y value, even though at the 2 ends, there's actually only one x to one y. So other types of functions, we have one-to-many and many-to-many. Now these two aren't actually functions, so both of these are not functions, and that's really important to remember. The way that you can tell that is because they fail what's called the vertical line test. Vertical line test. And the vertical line test is where you run a vertical line or a ruler across from one side of the axis. So if you imagine your ruler being here, and you move it in this direction. So it will become here, and then here, and then here, and so on. And at each time, it only crosses my equation once. Whereas on this graph, the same thing happens. So as I move my ruler along, it's going to meet here, and then it's going to be here, and so on. And the same thing would happen if I moved it across my cubic. Whereas when we look at these ones, they actually fail the vertical line test, and so they're not functions. So the only functions are one-to-one and many-to-one, but we still need to be aware of the relationship. So looking at that relationship, here's my axis. So I have my x-axis and my y-axis. So this one could look something like this, for example, and it could extend in both directions. So on this graph, I have one x value going to many different y values. So I've got one x value going to many different y values. So one x to many y. And on this one, when I put my ruler on and I start moving it in that vertical line, as soon as I get to somewhere like here, it's clashing twice, and therefore it fails my vertical line test. The vertical line test can only hit the function at exactly once at each point, and here at that value of x, it's crossing the line twice. So if we have a look at the last one, the many-to-many function, now a many-to-many function could look like a circle, for example. So again, here's my axis. So a circle equation might look something like that. And at this point, now it's going to be quite hard to see this, but I can pick an x value and it goes to many different y values. So it looks as if it's a one-to-many, but I can pick a different x value and that too can go to those same many values of y. So I've actually got many values of x going to many values of y. So this one is a many-to-many function. And again, this one fails my vertical line test. When I put my ruler on and start moving it towards the graph, as soon as I go over the graph, it fails because it meets twice. Now another way of seeing what type of function you have is to use the mapping diagrams. So we looked at these before, and if I use the two examples I've got here, so for y equals 2x, the domain is 4, so the range is going to be 2 times 4. So this is my x values and this is my y values. So I've got 8, and then I've got 2 times 3, which is going to be 6, 2 times 2, which is going to be 4, and 2 times 1, which is going to be 2. Now it's worth noting that they don't have to go, these values here, the domain, they could be anything at all. These were given to me, they don't have to go in order, they can be anything at all. So each one x value maps onto one y value. So I can see there that it is one x value to one y value, so it's a one-to-one function. Now the second one is my function x squared plus 4. So I've got minus 2 going in, so minus 2 squared, that gives me 4, and then I'm adding on 4, so that gives me 8. And then the next one, I've got minus 1 squared, that gives me 1, and I'm adding on 4, which gives me 5. And then I've got 0 squared, which is 0, add 4 is 4. And then I've got 1 squared, which is 1, add 4, which is 5. Now I've actually already got 5, so this one could just go meet 5 as well. And then this one is 2 squared, add 4, so that's 4 plus 4, which is 8. And again, I've already got that one drawn. So this goes to this one goes to this one goes to this one, and this is where you've got many to one. So I have many x values going to one y value. And the same thing happens where I've got many x values going to one y value. It doesn't matter that you've got a one-to-one on this middle part here, it is still a many-to-one function.